The question is count submatrices with the top left element and sum less than k. In the question, you have to find the number of submatrices in which you have to include the first element, that is the top leftmost element, as well as you need to find that sum. If it is less than equals to k, then that submatrix is a valid one, and you need to return that number of valid submatrices. So let me make it more clear. Question basically will be provided with a grid of size n cross m, and there will be integer k, and you need to find the number of submatrices including the top left element, this element. So the submatrices will be in this manner. This could be one of the submatrices. This would be the submatrices, and you need to check the sum of the submatrices. If it is less than equals to k, then it's a variable. If it is greater than k, then you don't need to include that submatrix, and you need to return that number of valid submatrices. So this will be the submatrices like this. So it should include the top left. So you cannot do like if you're traversing for a, let's say you are at this column, then the submatrices with this element as the last one will be like this. Yeah. But how will you find the summation from this? You cannot traverse again like in the grid, then the time complexity will be like for traversing each and every cell will be in cross n only. So you cannot afford more time complexity. Like the constraint for n is up to 10 to the power 3. So n square is acceptable, but n cube would not be an acceptable solution. Or n to the power 4. So n square is the maximum acceptability. So you can store it in a, let's say there is another matrix. We'll initialize this with 0, and every cell will be containing the sum of the submatrix. Like if you're standing at a particular cell this, then it will be containing the sum of the submatrix this with this element as the last, like the right bottom element. If you're considering this element as the right bottom, then the submatrices including the topmost also, top left, then the sum of this matrix will be stored by this particular element. So we'll be creating that matrix in which every cell will be representing the summation of the submatrix including that particular element as the bottom right. So if we are capable to calculate that matrix, then we can check, let's say that matrix name is mat. If mat of ij is less than equals to k, then so you can increase your answer. So the basic thing is we need to calculate that mat. And how we can do that? So let's say you have a sum for this submatrix, let's say over here, and for this you have a submatrix over here. Like this element is storing the sum of the submatrix with a red one, and this particular element is storing the sum of the submatrix, this blue light. Now you need to calculate for this particular element. How we can do this? So we can do this by, let's say this is sum 1, the red one, and the blue one is sum 2. So we can do sum 1 plus sum 2 minus, because this one got included and this got included, and this particular thing, the white one, got included twice, and we need to now exclude this once. So if we will also have this sum, so that if, let's say this is sum 3, so minus sum 3, as well as you need the value at this particular cell, that is grid ij. If we need to calculate for grid ij, then what we can do is, let's say mat of ij would be simply mat of I minus 1j plus mat of I j minus 1. This thing is for over here, and this thing for now. We need to exclude this once. So that is mat of I minus 1 j minus 1. Now you have the sum of this whole thing. So you need to include this grid of ij so that you will have the submatrix sum ending at grid of ij. Now you have the submatrix sum for ij column ending at this particular element ij. So you will use this formula to calculate for the summation of ij itself. So now you have the summation. You can add a check condition like if mat of ij is less than equals to k, then answer plus s, and you need to return that answer only. So that's it. Let me show the code and it will be more clear. So what you can do in the question is first just take out the number of rows and the number of columns from the grid, and we have initialized the matem with 0 because initially we don't have any sum. Now we are traversing through the each and every cell. If I is greater than 0, it means we are at the second row. So we have some row previous. So we need to include that sum also. So what I'm doing is I'm just adding I minus 1 j. And if j is greater than 0, then I need to include ij minus 1 also. So this is the previous column sum, and we need to exclude like the common area got included twice. So we need to exclude it. If I is greater than 0 as well as j greater than 0, then only we can exclude that particular thing. So that is mat of I minus 1 j minus 1. So we have excluded that particular element, and after that we need to include the current element, that is the element present at I comma j cell. So we have included that in mat of ij. Now mat of ij is containing the sum of the matrix ending at ij cell and starting at 1 comma 1 cell. And because there's 0 comma 0 starting at the top left and the bottom right is I comma j. So this is one of the submatrix. So if the sum is less than equals to k, so then this is a valid submatrix. So we'll include this in our answer and we'll return that. So that's it. Thank you for watching.